as 2, 0. All divided by 3, 1 as 2, 0. So this one will be 2 or not 3. So the answer is correct. So it's correct. I'm putting some questions on the board. I'll give you a few minutes to go through and we come and discuss it. So 1, find the limits as x, y approaches -1 and 2 for 3. Function is x squared, y squared minus xy. So if we make the limit as xy, which is 1 on 2 minus 3 on 2. 2xy minus 3x squared y. Three the limits as xyz approaches 102. Function will be 4xz all on y squared plus z squared. So let's first do this. Do that for me. Okay. The first one, what's the answer?
The first one, so I got 7. I don't know.
You had 7.
Yeah, I had 7.
Yes, I also got 7.
Okay. And the second one?
Second, I have
Yes, so
The second one, so I got -3 on 8.
-3 on 8.
yes.
Any different answer? And the last one? The last one? Oh, you are not there yet.
The last one I got 2.
No. I had 2.
Oh.
Let's check the second and
So
the
I
last
got 1.
You had 1. Okay.
Yes, sir.
That's very. Let's work it together. Please, do you all have? Did you get this? I want to see if you have a different answer, then we work it.
Yes, please.
I'm still working.
We should work it.
I said yes.
Priscilla.
Yes.
Okay.
Let's work together.
Okay. So, and the solution for the second one, we have 2 into brackets, 1 on 2. Then -3 on 2. -3 -1 on 2, all squared. And -3 on 2. We know that this and that will be 1. So I have -3 on 2 here. The first one. This and that will be. Then what about this? Have 1 on 4. Multiply 3 on 2. So -3 on 2. This and that will be positive. Plus S 3 times 1 times 3 to be 9. 4 times 3 to be 8. I'll add this one. I have -3 on 2 plus this. You find the LCM. LCM is 8. This goes to that 4. 4 times that -12. So -12 plus 9. Yes, what will be the answer? -3 on 8. So, Priscilla, are you okay now?
Yes, sir.
Okay.
Thank you.
Come again.
I said thank you.
You're welcome. And let's go to the last one. Let's go to the last one.
Hello, sir.
Yes.
Please, my network. So the last question, I want to copy the last question. I couldn't copy the last question before.
Okay, copy it. That's right. They want me to read it for you. The last question is find the limit. I'm writing it here.
Okay.
And this one is to 102. And the function is 4xz all over y squared z squared. So these are the functions. So that means wherever we find x, we put 1, y we put 0, then z we put 2. So 3, 4, 1 or 2, all on 0 squared plus 2 squared. This will be 8. 8 on what? 4. And the answer is 2. The answer is 2.
Please, the second one, what was the answer? I just need the answer to confirm something. The second
The
question.
second one was a negative 3 on 8.
Negative 3 on 8. Thank you very much.
Yes. Okay. So let's also take another one. We are now moving to let's take another one. And now we have to find the limit as x and y approaches pi comma 1. Pi comma 1. This time is cos xy all on y squared plus 1. Second one, limit as x and y approaches 0, 0. Sine x minus y all on cos x plus y. I want you to go through this now.
So the first one, is it x and y approaches 7 or pi?
Oh, pi. It's pi. Not
Okay.
7. It's pi. Pi. So this time the pi, when x is supposed to is approaching pi. If you want to put the, pi in degree is what? Changing pi to degrees. Yes, what will we do? Pi radian is equal to 180 degrees. Radian is equal to 180 degrees. So keep that in mind. Radian pi is equal to 180. If you want to change pi to degrees, that's it. It's 180. So what will be the answer for this? Remember, if you put the pi there, it will be pi times 1, right? So it will be cos pi. All on 1 plus 1 is what? This will be 1. Y is 1. So 1 plus 1. That will be 2. And what is cos pi? Cos 180 is what? Is what's cos 180? Is 1. Is it 1?
Minus 1.
1.
So I think minus 1.
Yes,
Oh.
minus 1. Yes. Because 180 is in the second quadrant. It's minus 1. So this one, we got minus 1 on us, 2. Minus 1.
Hello, sir. Hello, sir. Sir, please, we can't hear you.
Now, I said, the board is clear. We cannot see anything.
Yeah,
We can't hear your voice.
I thought it was my end.
Can we see? No. It's a general problem.
Same here. I thought it was my end. You cannot see anything.
As for the blurriness, well, I complain, but nobody said it. It is very blurry, so I can hardly see someone most of the things. I think he's muted. Hello, sir. I think the course rep should alert him that he's been muted. Hello, sir. Sir, we couldn't hear anything.
As a question for this team and blog. This blog team and
Hello, sir.
It is like he's making polo.
Hello.
Hello, sir.
Yes, can you hear me now?
Yeah, we can hear you. We're not hearing you from the whole.
Oh, okay. Sorry. Sorry. Okay, can we continue? Hello.
Hello.
Can we continue?
Yes, sir.
Okay. So I said that for this, we put the pi inside, which we have what cos pi over what 2. I know that cos pi is what -1 and divided by. So we have this one, we have negative what 1/2. And when we come to this side, you know x is 0, y is 0. So 0 minus 0 is 0. We have sine 0. Then 0 plus 0 2 is 0. So cos 0. And I was asking what is sine 0? What is sine 0?
Zero.
Sine 0. Priscilla. What's sine 0? I have sine 0 over cos 0. Sine 0 is what? But we know that sine 0 is 0. And cos 0 is what? 1. Zero is 0. Then cos 0 is what? 1.
1.
So this is 0 over 1, which the answer was 0. Okay. Now let's move on. If there's no question. This time I have xy into 1 0 half y divided by x plus 1 minus 1. Yes, I want you to do that. So what will be the answer for this?
I think 0.
It will be 0. You think?
That's what I think.
Okay. What about you? Check the numerator. The denominator. Check it well. The denominator will give us what?
The denominator will give us 1 plus 0 minus 1.
So what will be the denominator?
So it will be 0.
0. 1 plus 0 minus 1 is 0.
Yes.
So you see that when you put in that, you have 0 over what? 0, which I
Yes.
said that it makes the thing undefined,
Yes.
right?
So you have to do something.
Whenever you have this, that means that the function, the limit of this function does not exist,
Okay.
right? The limit of this function does not exist. Okay, so we are moving on to the next subheading. That's how do we test to see that a function, the limit of a function does not exist? That's what we want to do. Now, if you have the 0, 0, you need to test whether it exists or not. So let's do that. That's the next subheading. Yes. Any problem? So let's go to limits that do not exist. Limits that do not exist. Limits that do not exist. So to test for limits that do not exist, please note this. When the function is given to you, you look at the x. Let's say that in 0, 0. The limit as x move to 0 and y move to 0. So if you put 0, 0 inside, that is giving you 0 over 0, or the numerator of 0 over something, and it's equal to 0. What do you have to do? First, you look at the behavior of the function when x is approaching 0. So to illustrate it, we want to look at the nature of the function when the curve is moving towards the x-axis. Also, when the curve is moving towards the y-axis, what will happen? So moving towards the x-axis, this is your y-axis and that is your x-axis. So as the curve moves towards the x-axis, and we want to look at the behavior. Know that on the y-axis, on the x-axis, y is equal to 0. And on the y-axis, to x is equal to 0. So to study the behavior of the curve as it's moving towards the x-axis, that's why we are setting x is equal to 0 to look at what will happen. Then look for the result. So we note the result to be L1. And we also test the behavior of the curve as it's moving towards the x-axis. That one, you set y is equal to 0. And also look at the results. Let's leave it as what? L2. Now, if L1 and L2, the answers, they are not equal. So L1 is not equal to L2. If they are not the same, then you say that yes, the function, the limit of that function does not exist. Then you say that the limit of that function does not exist. I repeat. Now, we know that when you put the limit inside the function, you see that you have 0, 0. What we did. So we see that that function does not exist. But we need to test it and see and conclude that the limit of that function does not exist. Now, looking at the limits, x was moving towards 0 and y was moving towards 0. So we look at on the Cartesian plane the behavior of the curve when the curve is moving towards what? The x-axis, and also when it's moving towards the y-axis, in the direction of the x-axis and the direction of the y-axis. Now, when we find these two and the results are not equal, then we state that it does not exist. If the results are the same, we need to go for another test to conclude. But if they are the same, we cannot conclude on the first one test. We need to do another test to conclude that yes, it exists. But if the first test, the two are not the same, then you conclude that the limit of that function does not exist. Now, let's take the one that I gave you and see, illustrate it. Remember, I gave you this. The limits as x and y approaching 0, 0. The function was y x plus y minus 1. You saw that if you put 0, 0 inside, the result will be 0, 0, which is what? Undefined. And actually, you say that does not exist, but we need to test it and see. So what you have to do, you let x equals what? 0. So we are taking this equal to that. We are testing the function if it's moving towards what? The y-axis. See. Let's look at when x is 0, what will happen. So this time we are finding the limit. This one, s is now 0. You have the y to be the same. But this one, 0, y 0. Please still keep the y. Y is still there. We are not touching the y. So when s is 0, you have what? Y will be there. S will be 0. So 0 plus y minus 1. Now, when you have this, what do you get? This one will be the limit. I should write at the top here. I don't know if you can see. So this time we put y. So this one will be y mapping to 7. We have y divided by y minus 1. Then you put y inside the function. So you can be the graduate. Now we are finding the limits. This time is y mapping to 0. Y on y minus 1. So wherever you find y, we put what? 0. This one is 0 on 0 minus 1, which is on 0 over minus 1. You know it's equal to 0. Please, do you understand the first step? So we first put in s is equal to 0, then maintain the y. Don't touch the y. So you find the limit as s is approaching 0. And when we did that, we have this. Then we go on to setting the y to 0. See that we have the result to what? 0. And let's go to when y is 0 first. This time, let y is equal to 0 first. We find the limits. This time, x will be there, y 0. Mapping to x being there, 1. So the function was what? Y, x plus y minus 1. Now, wherever we see y, we put 0 there. Which what? 0, yes. Over what? This one is 0, right? The x will be there, and it will be this. So let me write the limits as x approaches 0. Y 0, we have 0 minus 1 as x minus 1. So, what will be the answer? This one was also equal to 0. So how do you conclude? Please, are you okay now? The silence is consent. So first one, we saw that we have 0. The second one, we have not. So you can see that L1, that's the first one, is equal to 0. And the second one too is equal to 0. So here we are saying that L1 is equal to L2. Now you need not to stop. You have to also try another one. Where for that one, you let x is equal to what? Y. So wherever you find x, you put y there. This time they are the same. If they were not to be the same, then we conclude that does not exist. But you see that both of them are the same. We move on to another line where y is equal to what? X. If y is equal to x, let's look at what will happen. For that one, to find the limits. And we are saying y is equal to x. So this one will be xx into what? Wherever you find x, put x there. You have y. This one. This one. This will be x. Column. X plus what? X minus 1. To the x or not, 2x minus 0. So we are going to find the limit of this. Please make this one 0. Because x was moving to 0. So we are now finding the limits as x is moving to 0. X on 2x minus 1. So this one too is 0 minus 1, which is equal to 0. So you see that whatever we do, we are getting 0. So this one, the limit of the function what that we are looking for exists. Let's look at another function. find the limits x, y. This time 0, 0. Have x, y on x squared plus y squared. We want to check if this one exists. First, set x equal to 0. Then we come and set y is equal to 0. And see if the answers will be the same. So solution. Let x equal to 0. That means that I find the limit as x, y here. So this will be 0. I still maintain my y. X, y on x squared plus y squared. So wherever I find x, I put 0 there. So this one will be the limit as y approaches y. This one will be 0 on 0 plus y squared. Yes.
So please hold on. As we let x equal to 0 and
Yes.
x and y approaching limit of x and y approaching x over 0, we have to substitute wherever there is x, 0 into wherever there is x, right?
Yes.
So from there, you said that we repeated x, y all over x squared plus y squared.
No,
Then
we
you
are
went for that.
find the limit. Sorry, we are find the limit of this.
Yes.
Where x map to 0, right? But the y
Yes.
will be maintained.
Yes.
So this is what we want to find the limits.
Yes. But
And
I
it's
don't
not
understand why
giving
you
us
went
all.
for that.
Come again.
I don't understand why you went for that by stating lim y up lim when y is approaching y.
Y is approaching. Now, when we finish this one, we come to. We are going to find the limits, right? Okay, so this one's supposed to be 0. Sorry.
Yeah.
That's what we are talking about.
Yes. Yes.
Okay. Because it's
shouldn't
0, 0. So we start with this one, then we
sir,
come to it.
so shouldn't it be y approaching 0?
Come again.
X shouldn't it be x approaching 0?
This
Because
one.
you are putting the next one equal to lim. Yes, lim.
So
Shouldn't it be
this one is mean where y is approaching 0, but already this one is 0.
okay?
So even if you find a 0, it will be 0. That's what I want to say.
Okay. Okay.
You get it? This one, so far as the numerator is 0, the whole thing will be 0.
Okay.
So even if you find the limit as y is 0, you get 0.
But I'm saying we put over here. You said y equal to 0. But over here, look at it's just the x that have been put to 0.
Yeah.
No. Where the y equal to 0. When you go further into the bracket.
Okay. Just look at it. If you put this one here, you are saying that s is equal to 0, right?
Yes.
So this one will give me 0.
Yes.
This one will give me 0.
Yes.
Then what will be the result of this?
The result of this will be 0, undefined.
The results will be 0. So we are finding the limits. We are now going to work on y.
Okay.
Y is 0. So what will be the answer? It will be 0.
It will be 0.
Because there is no y.
Okay.
Are you okay now?
I'm okay, sir.
Okay. So now let's move on. Can we move on?
Yes, please.
Okay. So now we want to also set when y is 0 first. I want you to do that one too. Before you come to the x. When y is 0 first. Remember, first one, you set the x to be 0 before coming to y. But this time we want to start with the y. Start when y is equal to 0. Before we come to the x. So what do you get, please? Okay, for that one to let's do it together. When y is 0, we have the limit. This time we have x, and we have y. That you are setting y to be 0, right? So we have this.
Yes.
And what is the function? The function is xy, x squared
Plus y
z
squared.
squared
X squared plus y squared.
minus 1, right?
No, there is no minus 1. Or there is.
There's minus 1. Or there's not. Okay, there's no minus 1.
There's no minus 1.
Okay, so let's have this. So if you find this, so we are putting wherever you find y, we put 0 there.
Yes.
And so I have this one, the limit, right?
Yes.
This I'll
So
set
then-
it to be what? 0.
0.
And this one will be 0 over what?
X squared
X squared plus 0.
plus 0.
Right. So I'm now going to find the limit as s moving to 0. This one will also be 0, right? The answer
Yes.
is 0. So you see that the first one, it was 0, right? And the second one to be 0.
Yes.
So we say that L1 is equal to what? L2.
L2.
But we need to test it and see, right? Go for another test. Go for another test. So for that one, we will set y is equal to what? X. Y is equal to x. And when we set y is equal to x, we have the limit as x and y. This one is x what? X. Y is equal to x. Let's go to the x, y, the x squared plus what? Y squared. So what will be the answer? So xs what? X squared, right? All or not? X squared plus what? X squared. This time we are finding the limit as x. This time the x will be approaching 0. I want to be this. This one will be the limits as x approaches 0. X on 2 x squared. So you get what, please? What do you get? 1/2. And if you find the limit as s approaches 0, 1/2 is the same as what? 1/2. Now you see that when you set y is equals to x, yes. Please, are you okay now? How you move on? When we set y is equals x, you see that we didn't get 0.
Yes.
For that one, we had what? 1/2.
Mhm.
The first
Yes.
one was 0, second one was 0. Now the third test is not giving a 0, which is this 1/2 is different from the result that we had. So we conclude that the limit of this function does not exist. The limit of that function does not exist. Any question here? Now we see we set x is equals to y. So
Yes.
where we find y, we put nz.
Yes.
So we had this. Then we put x here, nz. So that one was what? To be x squared plus x squared, right? All right, you see that we are putting x in place of y. So this one will be in terms of x. That's why we are setting x to what? To 0. Remember, the original one was what? 0 what? 0, 0. After moving x to 0, see, this will give us that. This and that will give us 2x squared. It will give us 2x squared, where x squared will cancel x squared. If x squared cancel x squared, we get what? Half, 1/2. So we are now going to find the limit as s approaches 0, 1/2. There's no x here. That will turn this one to 0. So we still have a constant that is what? 1/2. So setting y is equals to x, we didn't get 0, but we have what? 1/2. So this result is different from the original one that we had. Since they are not the same, the three tests are not the same, we conclude that the limit of this function, the limit of the function that was given, does not exist. Are you okay now? Yes, you need to understand this because you have question on that, so you need to understand it too. Let me look for another one. So that you can try it on your phone. Okay, so let's go on to the next one. This as x and y approaching 0. This time we have x, y squared all on x squared plus y exponent 4. We have to show whether the limit of this function exists. We have to show whether the limit of this function exists. Yes. So we first set out s is equal to 0. If we set s is equal to 0, what will happen? You get 0. You do it and see you get 0. So far as this product is here. If you set s equal to 0, you get 0. You set y is equal to 0, you get 0. But do you conclude that so far as these two are given as 0, there exists? No. So we go on a different test. Go on a different test. Now let's see, going on for a different test. Now you can see that this and that, a ratio. Right? Now this is y exponent of 4. So I can set y is equals to, sorry, x is equals to y squared. So that here, the exponent here and the exponent there can be the same. To be easier for me to cancel out. Now if I set s is equals to y squared, I'll put y squared here and put y squared there. Or I'll put x here and put x there. So let's do it together. Let's do it together. We were given this y, this time 0, 0. The function x y squared on x squared plus y is equal to 4. So we have to show whether the limit of this function exists. First, set x is equal to 0. And we are finding the limit x is equal to 0. And this means that 0 will be x, but we maintain the y. We have this y squared on x squared plus y squared. We are finding the limit of that. So wherever we find x, we put 0 there. And the next one is to find the limit as y approaches 0. That's the next one. But the limit, when you put this one, it will be 0 times y squared. That will be 0. And this one will go to 0 plus what? Y squared. So it's 0 plus y squared. And it will be the limit as y approaches 0, it will be 0. Whatever is here is 0. If you find the limit as y approaches 0, the result will also go to 0. Please, any question then before we move on to when y is 0? Okay. Now let's set y to be 0. We are setting y to be 0. If you set y to 0, in the limits, I have this one, y is y here. At x will be the same, y will be 0. So it will be x y squared on x squared y form. So y is moving to 0. Now this time I can find my x moving to 0. And this one got 0 already. Then x squared plus 0. So here I'll find the limits as s approaches 0. This one will be 0. Find the limit as s approaches 0. The function of 0 is 0. So you see that the first test gives us 0, second test is giving us 0. So do we conclude that the limit of that function is no? Do another test. Do another test. And the test, we saw that the one that we did first, we said that y is equal to x. But this time, look at the function given to us. Look at the function. So if we let y is equal to x, it will be easy for us to do our cancellation. So the 3 will be here. If x is equals to y squared, so wherever you find x, you put y squared there. Wherever you find x, you put y squared. That one will work. So let's set that one, then find the limits. So this time, when x is equals to y squared, this time we find the limits x, y, x moving to y squared, so we have y squared, now this one to y. We maintain the y will change the x. The thing is x y squared on x squared plus y x squared is 4. So we're going to put y squared here. If we put y squared here, please the y is still maintained. So we have a limit as y approaches the original one. So this one got yes. Y squared times y squared be y is 4. Wherever we find x, we put y squared there. So this one will be y squared all squared. Then write it y squared all squared plus y is 4. Now we have the limit as y approaches 0 of y is 4. Y is 4 plus y is 4. So this one gives us 2y is 4. The limits as y approaches 0, y is 4 over 2y is 4. So this and that will cancel. And last, I'll find the limit as y approaches 0, 1 over 2. But the answer is 1 over 2. So you see that when I set y is equals to x equals to y squared, I didn't get 0. I had what? 1 over 2, which is different from the original one. So I conclude that the limit of this function does not exist. The limit of this function does not exist.
Hello, sir.
Yes.
Yeah, so said it's from this second solution, it means that when we are doing the third search, you don't always say it x is equal to 0. You have to look at the equation before you set
Come
your
again.
test. I'm saying that
Mhm.
comparing this one to the previous one that we did, where we say x is equal to y.
Mhm.
This one we said x is equal to y squared.
That's good. Yes.
Yeah, and I'm saying that it means that it is not constant. It's not always where you say x is equal to y, but you have to look at
No.
the condition.
Yes. The function given to you. Yes.
Okay. Thank you.
You're welcome. Okay, let's take another one. So we are looking at different questions. Please pay attention to them. Pay attention. Okay. This time I have to show that this one exists, but does not. So this time I have y is equals to x plus y minus 1. As I want you to work this time, x is moving to 1 and y is moving to 0. So I want you to try that one too. Yes. So let's all do it together fast. 9. So what do you have to do? You see that when you put this and that, you get 0, 0. So we have to do them gradually. So we are setting s is equals to what? 1. Please take note of that. You see that the previous ones were 0, 0. That's why we are setting s equal to 0 and y equal to 0. And this one is s setting to what? 1. So we set it when s is equals to what? 1. We want to do that first. So let's go on to do the limits of x, y. So this one will be 1, y will still be there. So we have what? Y, x plus this minus 1. So this one will be 1. Then what will happen? this and that. So we have the limit as y approaching 0. Yes. This will be y on this is 1 plus y minus 1. This and that will give me 0. So if you can see it well, this and that will give me 0. At the end, I have the limit as y approaches 0. To be y over y. I know y over y is what? 1. So to conclude, we now find the limits as y approaches 0. Answer is 1, which is what? 1. So you see that if you set the x first coming to the y, it works. You have 1. Then we'll also work the other way. If you get the same thing.
Hello, sir. Sorry.
Yes.
So the limit that this y approaches 0 into bracket y over 1, y over y.
Mm-hmm. So y over y, if you divide y over y, what do you get?
You get 1.
So then you come and find the limit as y approaches 0, right? The function is now 1.
Okay.
That one will be 1.
Okay,
Don't put the values there.
Okay.
Divide it before you come out. If you put it there, to be undefined.
Okay, thank you.
Simplify it before you put it there. Now let's go to the next one. This time when y is equal to 0. We start from when y is equal to 0. Because that's one of the limits. We have this time x will be 19. So x will be 1. Right? Then y is equal to 0. So x will maintain x. Y will be 0. That's the first thing. So I have this or not x and this 1. So we are setting y to be 0. If we set y to 0, what will happen? This will be 0. Now I'm writing the limits as s approaches 1. So this will be 0 over x minus 1. 0 over this one is the same as what? 0. We are finding the limits as s approaches 1, function 0, which is 0. Remember the first one we had what? 1. And the second one we are getting what? 0. So how do you conclude? Are they the same? They are not the same. It says the L1 is not equal to L2. The limit of this function does not exist. The limit of this function does not exist.
Sir, please, you are writing the 1. You are blocking the where you are sitting.
Okay. I will move on. Okay. Let's look at limits that exist. We are asked to show that this limit exists. Prove that we done example that we just had do not exist. So limits s I'm listening. Hmm? Okay. Okay, so if there's no pressure, let's look at this. To evaluate the limits this one move to 0, 0.
Sir, please, can you tilt your camera up a bit? You're not seeing it.
So this I have x squared y all on x squared y squared. We have to evaluate this. Now let's look at this. You see that if you put in the values of x and y, what will happen? Please, and squeeze on the line. Okay, so you see that if you put in the value of x and y, what will happen? It gets 0 over 0. Now, we need to test and see if it exists. We are told that it exists, so we have to show, find the value, or show that it exists. We have to show that this, the limit of this one exists. So how do you show? So we use the same approach as we said. Let's try solution. And what are we going to do? We find the limit as this one move to 0, 0. So we have x squared, y squared. So now, please, I want you to set when s is equal to 0, y is equal to 0. I want you to do that. Then this one, please do it for me. When s is equal to 0, y is equal to 0. Set in when s is equal to 0. And tell me the answer. Then you set when y is equal to also 0. Yes, when S is 0, what do you get?
0.
You have the whole limit to 0. What about Y?
Yes. It's also 0.
It's also 0. And please set when Y is equal to X.
Okay.
Yes, what's that function?
There is 1/2.
Add 1/2.
Yes, please.
So let's set Y is equal to X. I didn't say Y squared. Y is equal to S squared. I said Y is equal to X.
Yeah, Y is equal to X.
If Y is equal to X, this one be X2, right?
Yes.
Then we have what? 2S squared.
Okay, I made a mistake. Okay.
You get it now.
Yeah, I got it now. So will it will be X/2?
You have what? X.
X/2.
So this one is X/2. And you find the limit. So remember S will be moving to 0. So also you have 0. Or to be 0/2. You agree? So you see that all the 3 tests that you've done is what? 0, 0, 0. Now we know that when you find the limit of this, it will give 0. You know that it will give 0. But we want a last confirmation. This is how we confirm it, conclude. So the absolute value of the function xy is, though this is the limit that we've already found. The one that we tested and you see that we have 0, 0. So here L is equal to what? 0. So this L here, this one will mean that we have the function. What function? The function is x squared y or not x squared plus y squared. And we subtract 0 from it. So that if you subtract zero, you get the same thing. Absolute value of what? X squared, this one, S squared plus what? Y squared. Now we want to do another test. That's the test that we said y is equals to what? Or s equals to y squared. So let's please, are you paying attention?
Yes, sir.
Okay. Now, instead of using the s equals to y squared, we see that this is x squared, that is y squared. Remember, we said s is equal to 0, y is equal to 0. And we said s equals to y. Now, let's set y squared is equal to 0. For this part, please take note. After you find your L and you subtract it from the function, and you have this, we set y squared is equal to 0. We want to.
Sir, please. Thank you.
Squared.
Come again.
We set y squared is equal to 0.
Sir, please come again.
Please, I'm confused.
We find out now the L that we find is from here when we set s equal to 0, y is equal to 0, then s is equal to y. You see that we have all of them 0, 0. That will be your L.
So, okay.
So you subtract the L, that's the 0 from the function that is given to you. Remember, we have the absolute value. So you have this. We have this one. So this is the result of subtracting this from that. Now the next step is to set y squared is equal to 0. We want to do this. We want to eliminate the y squared here. So we set y squared is equal to 0. Now if we set y squared is equal to 0, let's look at what will happen. So this expression that I have here is less than or equal to. I'm setting y squared is equal to 0. What will be it? Yes. I still have x squared. I still have x squared y. And this x squared plus what? 0. What would I get? This one will be equal to x squared y or what? X squared. And this will cancel that. So what will I get? I'll get on the absolute value of what? Y. I have the absolute value of y. When I set y is equal to y squared is equal to 0. So you see that this and that and that. So the numerator now becomes what? X squared. Where this x squared will cancel that x squared. I have it here. Then I'm left with what? Y. So this is the absolute value of y. Now what am I going to do? I'm going to find the limits as y approaches what? 0, the absolute value of y. Now find the limits as y approaches 0, the absolute value of y. What is the answer? Answer is 0. So you see that when I set s equal to 0, I have 0. Y is equal to 0, I have 0. Then s equals to y, I have 0. Then I also subtracted the L from the function and find the absolute value. Setting y squared equal to 0 also gives me 0. So now I conclude that I'm setting that yes, the limits of the function given exists. The limit of the function given exists. Okay, let's take another one. The more you saw, the more you understand. Let's take another one. So this time, you have to do this one till you find the length. So this time we have x minus 1 all squared, then x of x minus 1 all squared plus y squared. We have to show that this existence of this. Please, when you say length, think you know what length is. That's what.
Log.
Log will be base what? E. As a natural log. Log will be base E. So all the law of log regarding the length also to be. You cannot find log of what? Yes, a negative number. It's undefined. Log of a negative number is undefined. Then log of what? 0. Undefined. Yes. So what do you have to do first? What do you have to do? You see that if you put 0 here, it will undefined, right? I told you that log of 0. What do you have to do? The first set s is equals what? 1. First set s equals 1. And put it into the function. If you put it there, what will happen? If you put it here, s equals 1. This will be 1 minus 1. Put it in 0 here. This one will also be 0. Log 1 is 0. And this one will be 0. At here we got y squared. Y is to x. So next one, find the limit as y are put 0. 0 over y squared. 0 over y squared will be 0. So actually this one, if you take it one after the other, you get what? 0. It will be undefined. Do you understand the point I'm making? If you put all of these here, it will be undefined. But if you take them one after the other, like taking one first before coming to 0 to work, you get the answer to be 0. So I want you to do that.
So can you help us by putting it writing?
Come again. Come again, please. So here you let s equals 1. That's the first thing you should do. If s equals 1, you have the limit as x, y. So the x will be 1, y, you maintain y. Y will maintain. So it will be 1 minus 1 all squared, then y 1 all on 1 minus 1 all squared plus y squared. So this one will be 0. This whole thing will be 0. So 0 over, I'll find the limits as y approaches 0. This time I'm going to the next one, y approaches 0. Now, it will be the limit. This one will be 0 over y squared. 0 over y squared. You know that 0 over y squared is what? 0. Please don't go and put 0 there and say that 0 over 0. No. 0 over y squared is 0. So we are find the limits as s approaches 0. The function is 0. And this time, the limits as sorry, y approaches 0. The function is 0. And the answer will be 0. Straightforward. Answer will be 0. The next one too. What's the next one? We set y is equals to what? Yes, the next one is set y is equals to 0. So set y is equal to 0 and try that. I told you first set the limit gave you xy mapping to 1, 0. So we started with this before coming to that. And this time we start with this before we come to that. I'll do that one too. Let's see if we get 0. So let's call this. So this time we are starting is when y is equal to 0. So when y is 0, start. The limits as x, y. So we are saying that the x will maintain. We maintain the x, then y will be 0. The function was x minus 1 all squared. This one over x minus 1 all squared plus y squared. When you set this one to 0, this part will be 0. So let's go. To be the limits as s approaches 1. This time we are going to the end. We have x minus 1 all squared and x all x minus 1 all squared. Once y is 0, y will go off. Once y is 0. Then we can now cancel this effect. When we cancel that, we can now find our limit as s approaches 1. This time will be the what? Half the right is lane x. If we put 1 there, here, we put 1 here, that will be log 1. And we know that log 1 is also 0. So that one also will be 0. That one also be 0. So when we set s is equals to 1, also starting with y is equals to 0, we all have the same thing, 0, 0. So what's the next test? I hope you are following the procedure. The next test is what y is equals to x. Next test is y is equals to x. So when do you set y is equals to x? Look at the, please look at the limit given. 1, 0. So when x is 1, y is what? 0. When s is 1, y is 0. So what would be y? If I say y will be equals to what? Y will be equals to x minus 1. You agree?
No, sir. Please come again.
Remember, we are saying S is equals Y. Just look at this one. If I say S equals Y, we want to use a line. S equals Y. But we want to look at the relation between X and Y over here, looking at the limits. Now, S is 1. And what to do Y? To get Y is 0 here, right? Is that Y is 0 here?
Yes, please.
So what to be, and we are saying that S is equal to what? 1. So this relation will help us to get what? This one. But if S is 1, we subtract 1 from it to get what? 0.
Okay.
Are you getting the point?
Yes, please.
Now, if
No.
X is, this is the value. If S is 1, to get 0, we have to subtract 1 from it. But now we are setting S is equals to what? Sorry, Y is equals to X to get this limit. So let's go. So we have the limit as Y here. Now we are setting this one. So X will be 18. Y will be this. S will maintain, Y will be that. Let's go. Have X, Y, X minus 1, all squared in the X, all on X minus 1, all squared plus Y squared. So we are putting this one there before we come to X. So for S, but this one will be that. Let's go. This one will be equal to, please pay attention. Now we are finding the limits as X approaches what? The original one was 1. This time I have X minus 1, all squared, then X should maintain, yes. X minus 1, all squared, plus, what will be Y? X
minus 1.
all squared, yes. So X minus 1 we brought X minus 1. Let me still write it. The limit as S is equals to 1. Here will be X minus 1, all squared, then X. Like 2 brackets X minus 1, all squared. So this and that to go. Look at that. So I'm now left with the limits as S approaches 1. This time to what? Name X on what? On 2. S on 2. So wherever I find S, I put 1 there. And I told you, that's log 1 is what? What? 0.
0.
0 over 2, which is 0. You see that I have 3 tests. I've done that. They are all giving me 0. So I can now conclude that my L is what? 0. So now my L, that's the limit of the function. Confirm that is 0. L is equal to 0 now. Okay. So find the absolute value of the function f of x, y, subtracting the limit. I'm going to subtract. So I was giving what? X minus 1 all squared, then x all over x minus 1 all squared plus y squared. This is what I was doing. So minus 0. If you subtract that, you get the same thing. To be x minus 1 all squared all over x minus 1 all squared plus what y squared, then x. Now, what am I supposed to do? Remember the next step. Yes, what did I say? You said y squared is equals to what? 0. Remember that. So note the steps. So let's y squared is equal to 0. So if y squared is 0, whatever we have here will be less than or equal to. Certain y is equal to 0. We have x minus 1 all squared, then x all over x minus 1 all squared plus y squared. This one will be less than or equal to. So we are setting y to be 0. So it will be x minus 1 all squared. All on x minus 1 all squared plus 0. Plus 0. Now, after setting y squared to be 0, what will happen? So you have x minus 1 all squared, then x all over x minus 1 all squared. So this and that will cancel, right? Giving you what? Then x.
In S.
So now I'm now going to find the limits as s approaches what? Yes, let's look at the limit. It was what? S was approaching. Was it 1? Please look at the question for me. S was approaches 1, yes.
1.
S approaching 1. So we have the limit as s approaching 1. The length x. The length of 1 is equal to what? 0.
0.
So now, what do you say? So it what? We show that the limit of that function is what exists. The limit of that function exists. Okay. It's 10 o'clock now. Let's pause for 15 minutes. It's 6 minutes past 10. So when is 21 minutes past 10, you come back. Let's pause for 15 minutes. Then we come to end today's lesson. Okay. Hope you are all back. Now we are moving on to another subheading. We want to find the continuity of a function of two variables. We want to see which part of the function is continuing at a particular point. Continuity. Of the function. With two variables. At the point. Which part of the function is continuing at a given point. Now, when we ask you to find part of the function that is continuing, take note of these points. If the function is a polynomial, well, the first one, if the function is polynomial, an example is f of x is equal to 3x squared plus 5x minus 6. We'll give you different examples. G of x is equal to 7x exponent 6 plus 8 exponent 5 plus 2 exponent 2 plus 6. So any of these. Another example is m. X is equal to 3x plus minus 4. So all of these are examples of polynomials. So if the function given to you to find the point that the function is continuous and is in this form, you don't need to solve it or just try to equate it to zero. That the answer will be, now we know that f of x and y is said that this x and y belongs to all real numbers. So x and y belongs to what? All real numbers. So the real numbers that you are looking for, they are pair numbers. That's why we're using what? R exponent 2.
Sorry, sir. Sorry to cut you. The g of x, 7x, 7 raised to the power 6. Is
Exponent
it
6.
exponent 6 plus 8 exponent 5?
X exponent 5, yes, plus, sorry, suppose plus 2 x exponent 2 plus 6.
Okay, thank you. That's it.
Okay, so any of these, if you have them in form of polynomial, then it asks you to find the point where these curves are what? Continue. Now we are looking at the values of x and y. Okay. Please let me add this. These are examples of just one variable. Read this correction for me. So let's say that I have here y, then I have here y squared, change them. So this is y squared, and there's a 6. Yeah. So this one, we have that. But we have two variables. We are not dealing with only one variable. So we have two variables. So we have the function f of xy, which is this 3x squared plus 5y minus 6. Then g of xy is equal to 7x exponent 6y. Please take note. 7x exponent 6y plus 8x exponent 5 plus 2y squared plus 6. Then this one is equal to that. So anytime you have this kind of expression, they are in a polynomial form. They ask you to find the points where these curves are continuing. The first is in the polynomial form. If you read the answer, that will be the answer. So we say that the polynomial, that the function is continuing. Function is continuing. All real numbers. X and Y, they are all continuing each point. So write this one down. All polynomial functions are continuing on all real numbers. All polynomial functions are continuing. They are continuous all real numbers. All polynomial functions are continuous
on all real numbers.
On all real numbers. All real numbers. So that's the meaning of this. So you don't need to solve it. You become objective and you are asked to find the point where this curve is continuing. Don't need to solve it. Just write that the function is continuing on all real numbers. Okay, so that's the point one. Point two. If it's in a rational function form.
Sir. Hello, sir. Hello.
Yes.
Yeah, please. The last thing you wrote before the all polynomials functions, I didn't see that one. You wrote f of x, y into brackets.
So you wrote that s, y is 2, right? It said that.
Yeah.
So the x, y belongs to all real numbers. Now bringing these two because in 2 dimensions, right? The x and y. So that's the meaning. What I wrote, what I said is the meaning for all real numbers. The polynomial or the function will be continuous. Now let's go to if the function is in the rational form. Example is this: half f of xy equals to 3xy on x squared plus y squared. Now, if it's in this form, the form of a fraction, we are asked to find the point where this is continuing. The point where the function is continuing. Now, the moment you have this, please listen carefully. Our focus could be on the denominator. Is the part. Now, if the denominator here, that's the expression here, gives us 0, it means the whole thing not undefined. That means it will not exist. So to avoid that, what do we have to do? We accept all numbers, x and y, except any number that will make this part what 0. We accept any numbers, except numbers that will make this part of 0. So how do you solve it? And you let the expression here, you assume that is equal to 0. You assume that is equal to 0. So let's x squared plus what? Y squared is equal to 0. So how can this one be equal to 0? Yes. It can only be equal to 0 if x is equal to 0, y is equal to 0. Do you agree?
Sure.
Because it's squared, right? Both
Yes,
are
sir.
squared. So if x is 0 and y is 0, that will make this part undefined. Do you agree with it?
Yes, sir.
So how do you conclude on that? So we write that x and y, we said that x and y, x is not equal to 0, y is not equal to 0. So that will be the so x is continuing at all points except this. So you can also write it this way. X and y. So this x and y belongs to all numbers except x is equal to 0 and y is equal to 0. You can also write that. Yes. Okay, so you can also say that the function is discontinuous. The function is discontinuous when s is equal to 0 or y is equal to 0. Yes. Yes. Please talk.
Sir, please, did you say the function is discontinuous when x is equal to 0, y is equal to 0?
The function is discontinuous.
Discontinuous. When
Yes.
when
When
x is
s is
equal
equal
to
to 0 and y is equal to 0.
0. Sir, please read
Are you
that.
okay now?
Yes, I'm okay with the second point. Can you please touch on it a bit for me?
Can I?
That's it. The second point.
This one. Okay.
No.
So I'm saying
The
that
rational function where f of x y is equal to 3xy over x squared plus y squared. And you said we equate the denominator by 0, right?
yes, you avoid this part being 0. You avoid that.
Okay. So we avoid that by doing what, sir, please?
Come again.
You said we avoid that by doing what?
Avoid this part being 0.
We should avoid the denominator being 0.
Yes.
Okay.
So we look for numbers that will make this part 0 and avoid them.
Okay.
So we accept all numbers except those that will make this part 0.
Okay.
Right? Because of this square, this is squared and that is squared. It's only two numbers. Let me say two numbers or only one number that will make this part 0. If s is 0 and y is 0, right? Apart from s being 0 and y being 0, any number at all that you put there, they work.
Network keeper, yeah, right.
You get it? Are you getting the point?
Yes, sir.
Now you see, if s is 0 and y is 1, you can solve it. You can find a solution. If y is 1 and s is 0, you can find solution to it. But the moment both gives you 0, 0, that's where the problem is.
Okay.
So we accept all pair of numbers, except when s is 0 and y is 0. So use the word
Okay.
and.
Okay.
So I said that you can also present it this way. This s and y belong to all real numbers except s equal to 0 and y equal to 0. Are you okay over there? So let's take some questions and see. Try to find the points. Write the question on the board. Find all points. The function. F of x, y, plus x squared minus y. Yes, please, I'm coming. Yes. Yes, I'm listening. So where these functions are continued. Where these functions are continued. So please, let's write them. Do you have any question there? I hear people talking. Richard,
Yes, sir.
do you have any question there?
No, please.
Okay, so let's
No,
try
sir.
this. I want you to try this now. We are looking at said we should find all points where the function. So this, the functions like that are continuous. So let's do that. Let's hurry up. You have another lecture. What time do you have class? What time do you have the next lecture?
12 o'clock.
12 o'clock.
It's not 12,
Yes,
it's
please.
11:50.
11 what?
It's 11:50.
11:50. Let me look at your time. Okay. So let's try to finish by 11:20 or 11:10. That's by 11:20 or 11:30. We have to. Okay. So let's see how to solve this question. Remember I said that if you are asked to find all the points where the function this one
Sorry,
is continuous. Yes.
sorry, sir. So this with the greatest of respect, if we finish by 11:30, 11:20, that will not enable us. Some of us we've not eaten since morning, so we need to
Okay.
get something to eat
Time
so
do you want us to,
we can prepare for the next
what
class.
time do you want us to finish?
Say 11.
Also, 11 or
11.
11 or 10,
Yeah.
that would be okay.
Okay. So when it's 11:10, you prompt me, right?
All right, sir. Thank you very much, sir.
Okay. So let's see how to go by it. You see, remember I told you that anytime you have a function like this, and you have to find a point where this function is continuous, what do you have to do? Your focus should be okay,
The denominator.
right? Now remember that there's negative between them. This one is no addition. It's not addition. It's negative. And moreover, one is squared and the other is not squared. So you cannot think of negative and positive numbers. So you have to be very careful here. So what you have to do, let x squared minus y is equal to 0. Then you know that y is equal to x squared. So the moment y equals to x squared, what will happen? This part will be 0. The moment this y here equals to x squared, to be x squared minus x squared, that is what? 0. So avoid this y being the same value of what? X squared. Not the same value of x, but the same value of what? As what? X squared. So how will it be? So the points will be, yes, x and y. So I said that x and y belongs to the all real numbers, except x and y equal to what? Except y equals what? X squared. So we accept all numbers except y equals to x squared. Or you can write it that x and y belongs to all real numbers. Y is not equal to what? X squared. You can also write it that way. Y is not equal to x squared. Is understood?
Hello, sir.
Yeah.
Please, sorry, let me answer this question. I tried it earlier on, and then instead of doing it y is equal to x squared, I rather did it x is equal to square root of y.
X is equal to what?
Square root of y.
S is equal to square root of y. So that means that if we say that s is equal to the square root of y, then this s can never be negative. That's what you are telling me.
Okay.
But s can be a negative number or positive because of the square here.
Okay. Thank you very much, sir.
You're welcome. And let's move on to this one. Where do you
Sir,
have to
please.
look? Yes.
Sir, sorry. The final answer, you say S, X, and Y belongs to all real numbers except.
Yeah, I said that you can write it that way. Except S equals to Y is equals to X squared.
Okay.
Or you say that X and Y belongs to all real numbers. Y is not equal to X squared.
Okay. Thank you, sir.
You're welcome. Now, let's move on to this one. So how will you find the points? How will you find the points? You look at the denominator. So we are finding the points. This function is continuing except this one. So you let us y minus x squared minus y squared, right? Can I write it that y is equal to this squared plus y squared? Yes. So equal to 0. Then I'll say that x squared plus y squared, yes, is equals to what? 1. So if you find a squared and y squared and it gives you 1, it what? It means this plus 0. So whatever is here, x squared plus y squared, if it gives you 1, it means this plus 0. So you write them as what? This one, right? Said that x and y belongs to the all real numbers, except what? Except x squared plus y squared equals 1. The moment x squared plus y squared equals 1, the function becomes discontinued. The function becomes discontinued. Are you okay with it? The moment x squared plus y squared, you put them together and it's giving you 1. It makes this function or discontinued. So apart from this and that equal to 1, the function will continue. Okay. So let's answer these questions too. Then we come to the last part of the course. Okay, now the last one. What's the answer? This one, they mentioned it. Let's go.
Please, the last.
What? Unless the other. Who was in that? Patrick. Yes, Patrick. Okay, now we want the answer to the last one. Please hurry up and let's go. I want to see.
Yeah, I can see.
You have s cubed. Remember I told you s cubed y squared plus 5x minus 6y plus 7. This is the function. You are finding all the points that this function is continued. Remember I told you that if it's a polynomial, what do you have to do? You have to work it. Yes. Richard, do you have to work it?
No, sir.
Yes. So how do you find the points? Here. This is a polynomial. So all real numbers, right? So this one will
Yes,
be
sir.
all,
Yes, sir. All real numbers. Yes, sir. Yes, sir. It's true. I'll go through the note.
one need to work it, right? All real numbers.
So you can say that X and Y belongs to all real numbers.
Yes. No, you are playing numbers, right? That's why I've written it this way. So X and Y, they are all real numbers.
Please, we can see from your board.
You can't.
You can see from your board. It's too good.
I think
I feel see an iron here.
Hey.
As a network, no. As a
Honestly,
network, no.
myself is blessed for me a bit.
What's
And I
that?
said light reflection into I said a reflection of the light.
I mean, just said that it's not like
Yeah, I think about network, no.
okay.
Water is not ready for it, but yeah, I'll put it.
I'm still there here, macro voice no more.
See, never cry.
And yeah, young gun near Pona, Nyoye, Hushe.
Cost rep. Yeah, Pascal Cra.
In an impact, one area course rep, no creative platform, no, on an income.
Indeed, this a course revenue platform where it should be your. As or no, yeah, graphic design.
And the Madam Mary, a course rep.
I beg, please give it to different one person.
Why are you begging? You are a course rep.
Okay, you just give it to Akoko. Akoko will do that for us.
Akoka is not on this platform.
He is there.
He said, did he knew it?
I'll give it to Purity.
That me pebble. Richard, Richard,
Mama,
Richard.
your friend say. First class for Mary, Yama, uncle.
Me
First
me
class for
GP,
me.
me GP, me see GP kura me hu baby eba. What the Richard we Mary mo ye why?
Mary, Yama, and I mean, last semester, grade of the mama mass, my grandma, my last semester grading game.
Yeah, you ha no geometry and calculus now mo convert yeah. Omo ye ni D ana ye nya B na omo ye ni D. What are you doing about it?
I think it's 11 the crowd one thing. I don't think it's be away.
And see, maybe how will we get the course materials? So I'm not sure we get the number. So how do we contact him?
I think the general course rep will be having his number.
But I couldn't volunteer on your course rep for my
Richard, yeah.
I do my any personal. I've been doing easy. Mary, so now you're about first class lady. So I would so I mean your GB. You're my why? You're my best support too. Hello, Mary.
Say,
Pastor,
you
you're
just
my why?
volunteer and take that work. Do it on our behalf.
Yeah.
What do you think? Richard, please.
The pastor is you, master. The mine is hot. The mine is hot. And yet you may be a mom, but honestly, the mine is hot.
On creative platform now on add it. Say na yeah we.
Okay. Hello, can you hear me now?
Yeah, yes, sir.
Okay, so because of your time, right? Please,
Yes, sir.
the rep, where is he?
So I think he's on the other platform. He's not doing much. So
Okay, so those doing this, I think we have to form a
yes,
group,
sir.
then add me to that. Okay, so that we can.
Okay.
I can send you the
So please your
material.
contact. Your contacts.
It's on the, I think the timetable given to you.
Okay.
Are you giving the timetable? Okay, you write it down. 0548 0548 183561.
Okay. Thank you, sir.
0548 183561. So let's add me to the group and let's see. Sometimes this is what I normally have class lecture within the week. If you think that within the week we can find time to meet.
Okay,
So
sir.
that we finish as soon as possible. Okay.
All right,
Now
sir.
we are left I think the last part, then range and domain. That's what we're going to do. So maybe let's find a day within the week. Then we'll finish with that one before Sunday comes.
Yes, sir. So please, the one you just did, determine the following functions. The network was not stable, so we didn't hear anything. So I
This
don't know
one
if
or the
yes,
one on the
yeah,
board?
this very yeah,
No,
the
no,
one
I
on the
didn't
board.
even start. When I started the network,
Okay,
I saw that
okay.
the network was going.
Okay, sir. Thank you very
So
much.
next time when we meet, we will start with this question.
Okay, sir.
We continue. That this is the last part that we were doing, so that we will go back to the range and domain. So the next time we will start from here, end it, then go and do the range and domain of that function. Okay. Then we go
Okay,
to
sir.
unit.
Thank you very much.
Okay, enjoy the rest of the day.
Thank you, sir.
You're welcome. So I'll be waiting for you to add me to the group. Bye-bye.
Mr. Richard.
Hello, sir.
Mr. O creative group, I have 2 sentences. Different sentences. They enjoy the way.
Pacho you, Mati.
Okay.
I'm sure.
Oh, inshallah.
What are saying? Hello, Mary. Thank you.